Hello Year 12s. This video is for Learning Intention 32 and we're looking at rectangle rules. So this is finding the area under a curve using geometry. So by finding the area of rectangles. I've picked this question from the exercise because it has absolutely everything you need to be able to do for this learning intention. So if you can do a question like this comfortably, you're completely set for this learning intention. So here we need to calculate an approximation for the area under this curve from x equals 0 to x equals 3 with this interval width with left and right rectangles and then taking an average. So I'm going to define what all these words mean as we go through. But the first thing we need to do is get a sketch of this graph. And it's a calculator question. We can use our CAS. So let's get the CAS out. Now with the CAS, I'm going to show you how to do it with a document, how to define this function and then graph it. So that way it becomes very easy to use that function. So we go enter. We're going to add a calculator. So I've got a new document here. Now I want to add a graphing page as well. So I can go control, add a page here, plus page, and add graphs. So now I have a calculator and a graphing page, 1.1 and 1.2. The first thing you want to do is define this parabola. So there are a couple ways to do that. I'll do it the menu way. So you can go menu 1 that brings up define, and we're going to define y as a function of x equals x squared minus 4 times x plus 5, and it'll come up with done. Now the calculator recognizes y as this equation. So if I want to say find y of 2, I can just type in y of 2 and then it works it out for me 1, because that's 2 squared, which is 4, minus 8, which is negative 4, plus 5 is 1. So I can work out any coordinate, but I can also do the graph quite easily. So I'm going to pop over to my graph page and I'm going to graph y of x. Beautiful, look at that. We've got our graph there. You can change the window if you like, if you need to. I don't see the need to. I can see pretty clearly what I need to. So that's 1, 2, 3. So we're going from x equals 0 to x equals 3, and we only need this part. So let's start with our sketch. Going to grab Mr. Ruler. Where's our ruler? Here we are. And we're going to do a sketch of our parabola. Make sure it's nice and big. It will make your life easier if you do a nice big graph, as always. I've never told anyone to do a small graph. Do not sketch small graphs. Sketch big graphs. Alright, let's have another look. So it starts at y equals 5, and then 3 is about there. So we start at y equals 5. There we are, something like that. So this point is 0, 5. This end point, well, we can use our CAS to find the end point very easily, because we can hop over to our calculator page and the end point occurs at y of 3, so I just go y of 3 and look at that, 2. So the end point's 3, 2. That's quite nice. 3, 2. Alright. Now we've got to draw in our rectangles. So I'm going to do, let's do left rectangles in, let's see, left in green. Okay, so we'll start with the left rectangles. So left rectangles means that the left corner of the rectangle touches the curve. So what does that mean? Well, we need an interval width of 0.5. So actually, let's just mark in our intervals. So we've got 3. Well, the turning point's going to happen at, let's see, where does the turning point happen? Let's mark in the intervals. So the turning point's at about 2 there, and there's 1. So the turning point's at 2. Here, there's 3. There's 1. There we are. So we've marked those in. Alright, so left rectangles with a width of 0.5. So the left corner touches the curve. So we're going to do a rectangle here, like that. And see, the left corner touches the curve, and the width is 0.5 units. So that's 1 unit. So I've gone halfway. So that's 0.5. And we keep drawing rectangles like that. So the left corner touches the curve. These are left rectangles. Left corner touches the curve. Left corner touches the curve. Left corner touches the curve. And the left corner touches the curve there. Let's just make sure we've done that right. So, yep, they're all left corners of our rectangles. Well, how do we find this area? So now that we've got the rectangles there, we need to calculate the area. Let's set up an equation. Oh, before we do that, we need to find all these y values here. So we need to know the y value there. We need to know the y value there, there, and we need to know that one and that one. Okay, so we need to know these y values. What's the best way to do that? Well, we can use Mr. Kaz. We can hop over to our Kaz over here. Let's find some y values. So an x is 0.5, and in fact I can show you a trickier way to do it. I'm going to put in all the x values I need. You can do it with a curly bracket. I'll show you how that's done. So you grab your some control coming up. Here we go. You grab your curly bracket. Now you can list a bunch of x values and it'll spit out all the y values. So we need 0.5, comma, 1, comma, 1.5. Let's see, 0.5, 1, 1.5, 2, 2.5, 3, 2, 2.5, and we don't need 3 because 3's there. We don't need that value for that rectangle. Close the bracket. Whoops. Yep, bracket's closed. Look at that. So it spits out all the y values there in order. So that's quite handy. So we've got 3.25 to 1.25. So let's put those in for now. So we've got 3.25, 2 and 1.25. 3.25, 2, 1.25. What else do we have? 1 and 1.25. Okay, so those are the same. So I've drawn that quite badly there. So these are the same, these two rectangles. So we'll call that 1 there. 3.25, 2, 1.25 and 1. Now we can find the area under the curve. So let's call this a left rectangle. You can call it what you like. And it's going to be, let's see, so the y value is 5 times a half. So 5 times a half plus 3.25 times a half plus 2 times a half. And then we have plus 1.25 times a half. And then 1 plus a half. Oh, sorry, plus 1 times a half. And then plus 1.25 times a half. Alright, Mr. Kaz can help us out here. So what have we got here? We've got 5. And I'm going to take out the half. I'm going to factorize to make calculating easier. So 0.5 times 5 plus 3.25 plus 2 plus 1.25 plus 1 plus 1.25. Close your bracket. What do we get there? We get 6.875. 6.875. And to be nice and precise, because it's an area, we usually write units squared. Or you can, another way you could write it is square units. So you could write square units if you liked instead. It shows that you understand what's going on, that you understand that you're calculating area. So that's left rectangles. What about the right rectangles? Well, if the left rectangles mean the left corners touch the curve, the right rectangles must mean the right corners touch the curve. Let's do our right rectangles. So there's one. Oh, that was a bit sloppy. Let's try again. There's one. And then we have one here. So these are our right rectangles here. So I've got the right corners touching the curve. So that's actually going to have to go up here. The right corner touches the curve. And the right corner has to touch the curve there. So let's make sure we've got that right. That's a right corner, right corner, right corner, right corner, right corner, right corner. Well, how do we find the area of the right rectangles? Let's call it, what do we want to call it? A RR. Well, let's factorize to start off with. So we know that the interval is 1/2. Let's see, so it's going to be a half times 3.25 for that rectangle, plus a half times 2 for that rectangle, plus a half times, we agreed that that was 1.25, plus a half times 1, plus a half times 1.25, and oh, I'm unsure about that one. That should be what is that? Hang on, have I done that right? X equals, yeah, 2. So that's 2. That's right. So that should be symmetrical as well. So that should be like that. That endpoint should be there. So it's yeah. So it's a half times 2 for that one. So plus 2. Alright, how do we do this? Well, we get out Mr. Kaz, or we can be brave and do it in our heads. If you have a Kaz calculator, you would do it with your Kaz. 2.5, 3.5, 5.5, 7.5, 10.5, 10.75. So half of 10.75 should be 5.375. But obviously you check with a Kaz. You don't, you know, if it's, especially if it's a calculator exam. We're not goofing around here. But let's see if I got that one right. Plus, come on, plus 2 plus 1.25. Did I get the decimal there? No. Back we go. Back 1.2. It's being very stubborn. 25. 3.5 plus 2 plus 1.25 plus 1 plus 1.25 plus 2. Alright, 3.25 plus 2 plus 1.25 plus 1. Alright, what do we get? Beautiful, 5.375. 5.375 square units. So those are the left rectangles there. Those are the right rectangles. Here we want to average the left and right rectangle areas. So let's find that. I don't know, we could call it A, left, right, average. Call it what you like. The book probably has some nice notation. Do the average. 5.375 plus 6.875 over 2 gives you the average. What does that give you? Tell us, Kaz Calculator. 5.3, oh, I can't see the numbers. 5.375. So I can go up and grab that. Up. Come on. Up you go. It's not going up. 5.375. This is being very stubborn. 3. I'm not sure what's happened to this, Kaz. 5.375. Yep. Plus 6.875. And let's divide that by 2. 6.125. So 6.125 units squared is the answer for C. Now, these questions aren't tricky in that you already have all the skills to do them. They just require you to be pedantic. You need to be pedantic. Pedantic means very fussy and very careful. If you're very fussy and very careful and draw things carefully, draw them large, label your axes, put in the points, take your time, then you're generally fine. So you just need to get a bit of practice, making sure you can be pedantic with these questions, and you'll be right. And if you have been, thanks for watching.